Okay, just experimenting, exploring with this software. So far, it's pretty fascinating, and I haven't even began to touch the surface of what this software is capable of doing. Watching YouTube videos, I've been told that the learning curve on this is ridiculous, so I know it's going to take a lot of effort and energy and patience to get to use it to its full potential. But and this is just basic scratching the surface, but to start trying to illustrate the things that are occurring here. And now I've went in here and I can, as I've stated in former posts, indicating how important it is when you observe nature. Don't be so superficial with it. Really pay attention to what's going on symmetrically. And if we're talking about symmetry and proportion, a golden ratio, phi, Fibonacci sequence, etc., etc. But beyond that, and really outside of that, I'm not really focusing on that too much. I'm referring to more math. The term mathematics really, in essence, only means logics. It could be, mathematics can be demonstrated in a lot of ways. Equations, geometry, all sorts of applications mathematically. But what I'm referring to is an abstract and a very unorthodox form of mathematical logic that's derived from intuition and really different and unique methodologies of perceiving, perception, observing, and paying close attention and scrutinizing anything that you observe. In this case, we're observing the human anatomy. And of course, I'm utilizing muscular male figures because the definition, the curves, the contours, the full potential of the body muscles is obviously more demonstrative when using a muscular form versus just a natural form, or even a plump form, which would obscure the definition of the muscle. The pure, unadulterated, full geometric potential of the. That's why I'm using bodybuilders. But just real quick, just to illustrate, if you look at this, this is the bicep, this is the deltoid here, this is the pectoral, and I'm just beginning. And this will be a little bit vague here, but I will demonstrate that what I'm about ready to show is a semblance here, a similarity, will be vivid as this continues. But you notice here, if you notice this shape here, the bicep, looks like the top of a turtle's head, looks like the eye, and of course the mouth, the beak. And you see its head forming, coming under here. And then you see what appears to be, formed by the deltoid muscle, a shell of sorts. Now, of course, it's a strange shape. It's not a shape that's associated with the shell, but if we kind of clip this here, which I'll start doing in Photoshop, we'll see the semblance of a turtle. As we proceed, I'm going to show you that the animal symmetries that I show that's on the human anatomy, they're distinct. A person could mathematically go in and measure these symmetries of the animals and see that they are symmetrically, proportionally consistent with what's going on in nature from a golden ratio standpoint, Fibonacci standpoint, pi standpoint, actually. I'll be getting into descriptions of pi. Very unique things I've discovered about the pi value as well. But anyway, you see the kind of a semblance of a turtle there. Now, it's important that we, again, magnify and minify. So over here in Photoshop, it says width here, 1022. I'm just going to change that to 20. 20. And let's see what happens with this image. You see it's magnified. And of course you got the... Now again, this will become more distinct. Right now I'm just playing around and I just threw an image in here, a random image, and starting to work with it. So I'm not into the complexities of it right now and really elaborating on it too much. But okay, now let's go in and minify. Obviously the opposite of magnify, just contract it. So instead of 10, I'm going to go to, let's say, 5. And of course, let's go a little bit lower than 5. Because a lot of times an image isn't so distinct, but when you start minifying it, that's the strangest thing that's happening, which is an associative thing that I've discovered here, is when you start to minify an object that just kind of looks like an animal, let's say an insect for real, when the when the human body is expanded, the symmetry of an insect will convert into the symmetry of, and of course it's there, of a ram. There is a full ram here. I'm not going to get into that right now, but I'll show it just in vivid terms soon enough. But as we minify, like for instance, the symmetry of an insect is not so dissimilar or disparate from the symmetry of a ram's face and horns. And I'll demonstrate that when we get into the praying mantis and all sorts of other insects. In other words, when you expand the human form, the symmetries of animals are vivid, expanded. But when you take the ram's head with the horns and you minify and start contracting it, that is going from the macro standpoint down, in other words, going from a mammal standpoint down into an insect standpoint, the geometry and symmetry of the ram's face will gradually start converting into the same geometry, consistent geometry, that would form a wasp's face, or a bee, or a praying mantis. So again, this is just quick descriptions, but all of this will become scientifically apparent with time.